You know, the human body is just packed with secrets. We think we know ourselves pretty well, but right now, there are things happening inside you that are completely beyond our everyday perception. Today, we're going to pull back the curtain on one of the most fascinating secrets of all.
So let me just ask you a question, straight up. Do you glow in the dark? I know, it sounds like something right out of a comic book or a sci-fi movie, doesn't it?
But turns out, it's not science fiction at all. The answer, confirmed by some pretty incredible science, is as simple and kind of startling. Yes, you do. We all do.
And hey, this isn't some metaphor for your awesome personality or your aura. We are talking about a real, physical, measurable phenomenon. You are, at this very second, emitting light.
So the big question is, why can't we see it, right? Why isn't the world just full of faintly glowing people? Well, it's because the light your body gives off, it's a type of bioluminescence, is 1,000 times weaker than the absolute minimum our eyes can detect. It's like a tiny whisper of light in a world that's built for shouts.
So what's actually causing this? How is our body making its own light? Let's dive into the science behind this incredible invisible glimmer.
The official scientific name for this is ultra-weak photon emission, or UPE for short. Now, the key phrase here is byproduct of normal metabolic reactions. This glow isn't some weird fluke, it's a fundamental part of the chemistry of being alive.
So how does this actually work? Well, you can think of it like a simple chain reaction. First, your cells are buzzing, constantly creating energy to keep you going. That process, though, creates these unstable molecules called free radicals. These little guys then bump into and react with fats and proteins inside your cells. And the result of that tiny chemical collision? A little particle of light, a photon, is released. And that, right there, is your glow. Okay, so you might be thinking, hang on, isn't this just body heat that you can see with thermal cameras? And that's a great question, but nope, they're two totally different things. The glow we're talking about is actual visible light, born from chemical reactions. Body heat, on the other hand, is infrared radiation. So your body is actually broadcasting on two different channels, so to speak.
And if you think that's cool, it gets even more fascinating. This glow, it isn't constant. In fact, some groundbreaking research out of Japan discovered that our inner light actually ebbs and flows on a very predictable daily schedule.
So, using these ridiculously sensitive cameras, researchers were able to capture images of this glow. And what they found was that it's not even across the whole body. It seems our faces, especially our cheeks, forehead, and neck, shine the brightest. And that's likely because there's just more metabolic action and blood flow happening there.
What's really wild is that our glow is perfectly in sync with our internal body clock, our circadian rhythm. It's at its absolute dimmest late at night when we're resting, but then it slowly builds up all day long, hitting its peak brightness around 4 in the afternoon. So what's so special about 4 p.m.? Well, it all comes down to your metabolism. That's typically when your body's engine is running in its highest gear for the day. A higher metabolism means more energy reactions, which means more free radicals, and, you guessed it, more photons being released. Your glow is basically a light show put on by your metabolism. All right, so if this light is 1,000 times too dim for our eyes, how on earth did scientists manage to take a picture of it? I mean, the technology they had to use is it's mind-boggling.
There's this quote from the PLOS Journal study that I think just perfectly captures the magic and the challenge of it all. They wrote, "The human body literally glimmers." It's such a great way to put it. But they also highlight that immense technical hurdle of trying to see that glimmer.
So get this, to even hope to capture a single one of these photons, you need a special camera that's been cryogenically cooled down to an absolutely bone-chilling negative 120 degrees Celsius. This insane cold stops the camera itself from generating heat or noise that would totally drown out the faint light coming from a person. And you got to feel for the volunteers in these studies. The conditions were just as intense. They had to sit, shirtless and perfectly still, in a completely sealed, pitch-black room for hours at a time. And because the glow is so incredibly weak, a single photograph required an exposure time of up to an hour. It's an almost heroic effort to capture something invisible. Okay, this is all incredibly cool, for sure. But here's where it goes from a neat party trick to something that could be a total game-changer in medicine. What if this invisible light could actually tell us what's happening inside our bodies? Here's the most important thing to remember. The brightness of your glow, it's a direct signal of your metabolic rate and the level of what's called oxidative stress in your cells. A brighter glow means more activity and more free radicals. And that connection is what makes this so incredibly promising for medicine. If we can learn to read that light, the possibilities are just, Wow, we're talking about things like cancer detection. Some studies have shown that cancerous tissues, because their metabolism is in overdrive, actually glow more brightly than healthy tissues. It's also being looked at as a way to measure UV damage on skin, or even to monitor the cellular stress that comes with diseases like diabetes or Alzheimer's. I mean, just imagine being able to check if an organ is healthy for transplant just by reading its light. It's amazing.
Think about it. We could be looking at a future with a totally non-invasive scan that doesn't use any radiation. It just reads your body's own faint natural light to create a live map of your cellular health. That's the incredible promise of ultra-weak photon emission.
So yeah, it turns out you are a living, breathing, and glimmering biological marvel. It really makes you wonder, right? If your body's been hiding its own light from you this whole time, what other secrets is it keeping?